Hello everyone and welcome to Pentagon. Today's problem is a bit different. We have the 3-digit number AAB, another 3-digit number ABA, and the 2-digit number CC, all summed to the 3-digit number BAC. We're given that each letter in this cryptogram stands for a different non-zero digit. What is the 3-digit number BAC? Please pause the video here if you'd like to try and solve this yourself. Right, first let's take a look at the units digits, the units column. From this, it looks like this problem is saying B plus A plus C is equal to C. Well, this is impossible because if we cancel out the C's, you can clearly see that this is saying B plus A is equal to 0. And this can't be, since B and A are two different non-zero digits. There is another explanation for this, however, and that is if once we added B, A, and C, we put down a C as the units digit and then carried a 1 over to the tens column. And of course this carrying 1 over is the same thing as 10 plus, it's an extra 10. So writing this as an equation, we would get B plus A plus C is equal to C plus 10. And now when we cancel out the C's, we get B plus A is equal to 10. Now this is valid, and this is going to be a very important equation. One of the 3 main equations that we'll be using in this problem. Alright, now let's look at the tens column. Once again, if we write this as an equation, on the left-hand side we have A plus B plus C. However, we have to remember that we carried a 1 over from the units digit to the tens, from the units column to the tens column. So we need to add that 1 in here. And this looks like it's equal to A. Once again, this is impossible because we can cancel out the A's, and we can also subtract 1 from both sides. And what we get is B plus C is equal to -1. Of course, this can't be. And once again, our only explanation is if in this column we put down the A and carried a 1 over from the tens column to the hundreds column. So let's rewrite this as an equation, and we get A plus B plus C, and don't forget the 1, is equal to 10 plus A. Since this 1 that was carried over symbolizes an extra 10. Now, if we cancel out the A's, we get B plus C plus 1 is 10, and when we subtract 1 from both sides, we get B plus C is equal to 9. And this is the second of the 3 main equations that we will be using. Alright, and finally, let's look at the hundreds column. This time, there is no column to carry over a 1 or a 2, so we can just write this simply as A plus A, and then we can't forget this 1 carried over from the tens to the hundreds. A plus 1 is equal to B. And when we simplify this, we get 2A plus 1 is equal to b. And this is our third and final equation. For a little bit of clarification, the reason that we cannot carry a 2 in either of these columns is because the values of b, a, and c would have to be at least 10 to satisfy these requirements, and so those are not possible. So the only values we could carry are 1. Right, now back to our equations. Let's look at the first and third equation. In our third equation, we have a value for b in terms of a, and in our first equation, we have an equation containing b and a. Well, we can use the third equation using our value of b and substitute that into the first equation. So let's do that. Since we have b plus a is equal to 10 and b is also equal to 2a plus 1, we can say 2a plus 1 plus a is equal to 10. When we combine like terms on the left-hand side, we get 3a plus 1 is equal to 10. And when we subtract 1 from both sides, we get that 3a is equal to 9. And finally, when we divide both sides by 3, we get that a is equal to 3. Alright, so we have one of our values. Now, we have the value for a, and well, we've got our first equation, b plus a equals 10. We can use this to solve for b. So we had b plus a is equal to 10, and a is equal to 3. Those were our values. So we can say b plus 3 is equal to 10. And when we subtract 3 from both sides, we get that b is equal to 7. Alright, we got our second value. We just need to find c. And well, let's hope we haven't forgotten our last equation, or rather our second one that we derived. We can now use this using our value of b to determine our value of c. So, using our second equation, b plus c is equal to 9, and we had that b is equal to 7, we will have 7 plus c is equal to 9, and when we subtract 7 from both sides, we get c is equal to 2. Right, now we have all our 3 digits, and the question was asking us for the 3-digit number BAC. Well, the 3-digit number BAC, using our values of B, A, and C, is simply $732. And that's our answer. Thank you for watching this video. If you liked it, please consider subscribing to our channel. Thank you all, and I will see you in the next video.